Morning, guys. How's everyone doing today? Go ahead and comment in the chat if you're here. Morning, Liberty. Alright, so there's one person's here right now. Give it a couple minutes, see if Rachel, Hunter, and Cole stop in. Alright, Liberty, it might just be you and I. I don't know. There looks like there's two viewers, but you're the only one who answered, so I don't know where the other viewer's coming from. But regardless, Liberty, let me ask you if it is just you. Where are you at in the practice exam? Because my intention is to go over the rest of problem 2, and then problem 3, and then 4. Rest of problem 3, 4, and then 5 as well. Because that was technically what was Monday during class, and then for homework. So I just want to see how far did you get, and then if you did get through almost all of it, then we can just talk about that. Okay, perfect. So, Liberty, would you rather have me go over the answers and then you can ask your questions, or do you want to go over just ask your questions now and we can go through his stuff? Three D was a little weird. Okay. So what about I don't know how delayed this is, so you might be typing out. There you go. All right, can you go through the answers for 3C and then walk through 3? Yeah, sure. All right, um so go to the third question then, Liberty, if you have that open. That was the one where they had a graph of f and then they give you what g of x is. So I know I went over 3A and 3B on Monday, so you should be all right with those. Let me just switch to my screen here. Yeah, okay. So let's go to 3C. It says on what open intervals, if any, is the graph of g concave up? Justify your answer. You should have gotten the intervals -5 to -2 and from 0 to 3. This one was really easy. We wanted to find when f prime of x essentially is greater than 0. So you find when f prime of x is greater than 0, and that would be the all it's saying is when is the slope positive. When is the slope of the tangent line positive? That's all that question really asked on the graph. And then for D, you said you'd like to go over. C was fine. All right. So let me switch over to my notebook here. And let's take a look at D. All right. So this was 3D. So it says find all x values in the interval -5 to 5 at which g has a critical point. Classify each critical point as the location of a local minimum, local maximum, or neither. Justify your answers. Okay, so I was confused at which points qualify as critical points based on sharp turns. Okay, gotcha. So what we're looking for, Liberty, is we're just saying when is g prime of x equal to 0? Well, we found this in step 3b, the comparison, because we're given what g of x is, but we're not given an actual function. So we can't just set a function equal to 0, use our calculator or whatever, and try to solve it. So instead, we have to be a little bit more creative. We have to figure out what is f of x with respect to g prime of x. And we found out that f of x was g prime of x. Those are equivalent statements, which means that all we're looking for to find the critical points is not the sharp turns. We're just looking for at what x values is f of x equal to 0. So, you just go to your graph, and you would see it's 0 at -2, and it's 0 at 1. So we're going to say at x equals -2, and x equals 1. All right, that was the key there. So it's not actually based on the sharp turns. It would be based on the sharp turns if, not necessarily the sharp turns. It would be based off of maximum and minimums. That's what we qualify as a critical point. A critical point is when there a maximum or a minimum occurs. So, other words, it has a slope of 0. Now, the only reason why we're not doing that is because it asks for g, not f. Okay, and I'll keep going. So we know that these are our critical points. Now, in order to find local minimums and maximums, we always have to make a sign chart. So our sign chart is just covering every interval that includes, every interval that starts or ends at the beginning of our interval or critical point. So for instance, you start at the beginning of the interval, -5 to -2, which is our critical point. -2 to our next critical point, which is 1. And 1 to our end of our interval, which is 5. Oops, just realized I was not on my notebook. Okay, so we're making this sign chart. Now I notice that I put for the sign chart, we're looking at what f of x is, and when I say what we're looking for the sine of f of x in those intervals, or that's the same thing as saying the sine of g prime of x in those intervals. And so all you got to do is look at your graph of f of x and just see, is it positive or negative from -5 to -2? It's negative. From -2 to 1, it's negative. And from 1 to 5, it's positive. The definition of a relative or local maximum or minimum point is when the derivative changes signs. So when g prime of x changes signs, that's when we have a local minimum or maximum. So you can see at x equals -2, does it change sign? Yeah, okay, you got it. Yeah, you look like you're good, Liberty. Exactly. No problem. So it sounds like, Liberty, maybe you thought that you were looking for maybe the derivative of f. Yeah, but the nice part is that g prime of x is equal to f of x. So you really are just looking at the graph, which kind of makes things a little bit easier. But yeah, I don't think I need to finish that. It looks like you're okay. Sorry, I keep blowing my nose. Okay, so if you're good with that, Liberty, let's go to 4. Let me know when you have your workout and the assignment open. Let's go there. And I'll do the same thing. I'll go over the answers, and then I'll let you ask any questions you got for those. Yeah, Liberty, absolutely. Okay. So let's start with 4. Like I said, I'll go over the answers first, and then I'll let you ask any questions you got on it. So this was, they had A, B, and C, so 3 parts. The first part, 4A. So we had to use a midpoint Riemann sum with 3 subintervals of equal length to approximate a value. So your first answer should have been 40.2. Again, 4A is 40.2. 4B says determine whether the actual value of fx could be 70. Explain your reasoning. You find out that the actual value could not be 70. That's not obviously the big part of the question. That's 50-50 shot at getting that. You got 20.2. Okay, so we'll take a look at that, Liberty. For B, though, like I said, we really just want to make sure that the process is good. So here's basically how you wanted to approach it. You know that f prime of x has to be less than or equal to 7. We know that the integral from 0 to 6 of f prime of x is got to be less than or equal to 6 times 7. Because there's 6 subintervals. Each subinterval has a maximum height of 7 because the derivative has to be less than or equal to 7. So essentially we're setting that integral from 0 to 6 of f prime of x less than or equal to 42. And then we just solve that, and then you should have shown that f of 6 has to be less than or equal to 62, which is obviously less than or equal to 70. So a lot going on that one. That one might be a good one to go over if none of that made sense or you had a hard time following that. Okay, and then for C, there was a part D actually. I'm sorry, I thought there was only 3 parts. For C, it says evaluate the integral from 2 to 4 of f double prime of x. This one wasn't too bad. All you're essentially doing is you're using the fundamental theorem of calculus, and you should have gotten negative 0.3. So for 4C, you should have gotten negative 0.13. And then D was just finding a limit. Your initial attempt at finding a limit hopefully was direct substitution. You find when you direct substitute that you get 0 over 0, which is indeterminate, which means you have to use L'Hopital's. Use L'Hopital's, take the derivative, numerator and denominator, plug in 0, bam, you get negative 8. So again, for D, you get negative 8. All right, so any questions you have on that one? Or what parts would you like to go over? All of it? None of it? You were good with 4. All right, do you want to go over 4A? Liberty, because you said you got 20.2. You should have gotten 40.2. I already know. I have a pretty good idea of where. I think you missed a quick step. We can talk about that one real quick if you want. Okay, so here's. It sounds like you had a pretty good understanding. So I think what you did was, we want to use this Riemann sum to approximate. And essentially what we're doing is we're approximating, because when we use Riemann sums with subintervals, we're approximating areas under curves, right? So also known as integrals. So we have this table from 0 to 6, and we want to find the area underneath that curve. We're going to do that, so that this is the notation, right? It's the integral from 0 to 6 of f prime of x. And then we want to use a Riemann sum with 3 subintervals of equal length. And so we know that we have it from... Okay, so I don't know, Liberty, that... Well, I'm going to keep going, because I'm not positive that's going to affect it substantially. So if I keep going here, I know that my interval is going to be split up into 3. So from 0 to 6, that means it's going to every 2 is going to be how it's split up. So from 0 to 2, 2 to 4, and 4 to 6. Those are going to be my intervals. So essentially what we're going to be finding is f prime of 1 we need, f prime of 3 we need, and f prime of 5 we need. Those are all our endpoints. So our subintervals, those are the endpoints of our subintervals. It says midpoint Riemann sum. So between 0 and 2, the midpoint is 1. Between 2 and 4, it's 3. Between 4 and 6, it's 5. So that's where I get those values. They give us these points. So 3.5, 0.8, and 5.8. I also know that for every single one of these intervals, my width is going to be 2. So I'm going through this quick because I think you probably got a lot of this stuff. Or maybe you messed up the interval part. So when you're actually finding your Riemann summation, you're going to do width times the heights. The width's always the same, so 2 times the entire quantity of each of these midpoint heights. So 3.5, 0.8, 5.8. And that's where you get 20.2. Now, the difference, though, is the question didn't ask us to just use the midpoint Riemann sum or just find an approximation for the area under the curve using the midpoint Riemann sum. The question asked us to approximate the value of f of 6. This was calculating an area. We want to actually find what f of 6 is. And to do that, we have to use the fundamental theorem of calculus. In other words, we know that the integral from 0 to 6 of f prime of x is equal to f of 6 minus f of 0. That's by the fundamental theorem of calculus, which means that f of 0 plus the integral from 0 to 6 of f prime of x is equal to f of 6. And that's what we ultimately want to solve. They give us what f of 0 is in the beginning of the problem. It's 20. So we just get 20 plus 20.2, and that's where we get our 40.2 from. So I'm assuming that was probably the last step was just the one step you forgot, it sounds like, because you have the 20.2. And then you just have to remember you have to add 20 to that. Okay, just let me know if that's good for you, Liberty, and we can move on. Cool. All right, so let's go to 5. Same thing with 5. I'll read out the answers, and then you just let me know at the end what kind of questions you have on it. So for 5, I told you to skip part D. That was using Lagrange error bound. I wasn't really too concerned about that, so we're skipping that part because that's not going to be on your AP test. So we're just going to do A through C on this one. The first one I can't really tell you the answer because the answer is what it says. Show that all you're doing is you're going to be doing taking a derivative. So when you're taking that derivative, use quotient rule and basically implicit differentiation. That one was fine. Okay, yeah. So that shouldn't have been too much of an issue as long as you used implicit differentiation correctly. B, it says, does G have relative minimum, maximum, or neither at x equals 4? Justify your answer. So you should have found, first of all, you should use the second derivative test. So you wanted to somehow reference that. And by using the second derivative test, you're going to find the first derivative, there's your critical point. So we definitely know that at x equals 4, that there is a critical point. And then you take the second derivative at the point 4, 2, and then you find that it's a negative value, meaning it's concave down. So you have a critical point. At that critical point, it's concave down. The only time that can occur is when there is a relative maximum point. So by the second derivative test, that's what you're doing. There's a relative maximum point at x equals 4. Okay, and then C was creating a second degree Taylor polynomial. So what you needed to find was you need to find y prime at 1, 2, and you needed to find y double prime at 1, 2, which you end up getting 3 and 8. You know my a value is 1 because the Taylor polynomial is centered about x equals 1. So you put that all together. Your general outline is the second Taylor polynomial. Let me see. Can you walk me through 5b? Yeah, I'll walk you through 5b. Let me keep going with C, and then we'll go back to that. So your general Taylor polynomial setup should have been h of 1 plus h prime of 1 times x minus a plus h double prime of 1 divided by 2 factorial times x minus a squared. So that's just like a general outline of a Taylor polynomial, and then you just got to fill in your pieces. So h of 1 is equal to 2. We know that. That's given to us. H prime of 1 is 3 times x minus 1 plus 4 times x minus 1 squared was your final Taylor polynomial. All right, so let's look over. Let's look at B, and then in the chat, just let me know if you need to go over C as well. Okay, so 5B. It says let y of g equals g of x be the particular solution to the differential equation. You said 5C was good. Okay, cool. To the particular differential equation, dy dx equals -1 plus y squared divided by x. Okay, so g of x is our particular solution to that. Now what we want to find is with these initial conditions, so where x is 4 and y is 2. That's what it says. So we want to find dy dx evaluated at the point 4, 2. Why do we want to do this? Well, we want to do this because this is going to give us it's going to tell us at this point, 4, 2, do I have a critical point? Because I don't have a critical point, then your answer is neither. It's not going to be relative minimum or relative maximum because the slope isn't equal to 0. So we basically have to find out, we have to figure out, is this true? Is this 0? That's what we're doing. And so we plug in -1 plus 4 over 4, right? Because 2 squared is 4, and then x is 4, which is -1 plus 1, which is 0. So that means I have a critical point. Okay, so I can rule out it being neither. It's going to be a minimum or maximum. Just a matter of what. Okay, so now the second part, to find out if it's a minimum or maximum, we have to find concavity. So we need to find, the second derivative of y, or the second derivative of dy dx, or y. Now to do that, that's something you found earlier. So that step should have been found in part 5a. Yeah, so 5a, you should have gotten a representation of that. And you could use whatever form you chose. So like obviously, you know, the whole point of 5a was to go through and like show that the second derivative is equal to that. So I'm just going to use from part A that exact answer. Okay, so you get 2 times y cubed, which means 2 times y is 2, so 2 times 2 cubed, which is 8. And then minus y squared, which is 4. 2 times 2 is 4. And minus 2 times 4 times 2. Should write it like that. Divided by x squared, so divided by 16. And I'll tell you what that equals. It equals -1/4, which is less than 0. So because -1/4 is less than 0, the second derivative tells us concavity. So a negative number for a second derivative means concave down. So we have a critical point that's concave down. Your final answer then would be, let me see if you can see this. Should be able to. By a second derivative test, there is a local max point at x equals 4. Okay, that's basically the outline for that, Liberty. Just let me know how that was for you, if you're good with that. And if you are good with that, Liberty, you can go ahead and get started on question 6. And it's just you, it looks like, so any questions you have as you go, just let me know. Yeah, no problem, Liberty. Did you see my explanation for the last problem? For 5B, did you get through that? Okay, cool. So I just said to start on 6A or just 6 in general. I don't know if you got that part as well, but I'll be here if you have any questions as you're going through it. Do we have to use the tangent identity in part A? Um, Inverse tangent, Liberty, yeah. So, yeah, exactly. Yeah, you're basically using you're gonna have to manipulate the fraction a little bit in order to figure out what it's gonna be. It's not, this part's pretty, like 6A, that part's a little bit challenging just because the way it is, just the way it's set up, but you're gonna have to manipulate the fraction a little bit, and then you're gonna, I think you already identified it's an inverse tangent. So the only difference is the inside of the inverse tangent and the outside are gonna be different numbers. So we can go over that if you want, but yeah, it sounds like you're on the right track. So Liberty, I don't know if you're still in here, um, but I would not be having a live office hour today. I'll still answer your questions. So if you have a question, just email me, and I'll try my best to explain it or type out the work for it. If not, Friday we'll have Friday to review. Friday's just a review day anyway. So any questions you have on this assignment, and then tonight's homework, Liberty, we can go over Friday. Or like I said, email me today, tomorrow, whenever. So just so you know, so you don't pop in for no reason. Are you almost done with number 6? Okay. Yeah, so if you want, we can go over A on Friday. Liberty, AB's about to start. I appreciate you being here. Hope you have a great rest of your day. I'll see you probably Friday. And AB people, welcome. How's everyone doing? Let me switch over. Hey AB, how you guys doing? Morning, Haber. Yep, absolutely, Liberty. See you Friday. Good morning, Andrew. Good morning, Alexis. Oh, man. Happy Wednesday. Hump day. Morning, Gidio. Morning, Jasmine. Well, guys, grades are officially submitted for the third quarter. So, third quarter is done. You guys are 3/4 the way through the year officially. Woo! That's actually pretty good. So, congratulations. 3/4. I'm 3/4 the year way done with my first year teaching. You guys are 3/4 the way done with your junior/senior years. I know it's sad to talk about, but I think it's officially not going to be happening. We will not be seeing each other again this school year, which really is upsetting, especially you seniors. Very upsetting. So I apologize for you guys. I feel very bad for you. Not ideal. Really, really stinks. But it's okay. We're gonna battle through it. Now we know at least, so we know what we're in for. At least we've had this preparation for, and we don't have to like wait on the edge of our seat. You know, they said it. That's how it's gonna be. Schools are closed for the rest of the year, so the school year, rest of the school year. So I have no clue what's gonna happen at the beginning of next school year, but that's way down the line. So this school year, though, for the fourth quarter, will entirely be online. I think part of, I think at least in terms of like from my perspective, I think it was motivating for me to think that there was still a chance that we would be back in school, and that kind of I think helped with this process and helped it kind of stay fresh and I don't know, I guess the excitement of it to continue because I was like, oh well, eventually we'll get back to normal, but unfortunately that's not the case. Now you guys are a little bit different because the core of our class. The core of the curriculum has already been covered. It's being reviewed right now, and you'll be tested on it, on May 12th. So not that long from now. So like this class is almost over anyways. So it didn't work out, but it wasn't the worst case scenario for us. I think we actually did better than could be expected with the situation. So I'm happy about that. But there is going to be like a while, at the end of the fourth quarter where it's going to be like, entire month of okay, what now? And it kind of stinks. I have a lot of sympathy with you seniors, those of you playing sports, those of you just in school, not being able to see your friends at school, your teachers. We don't get to send you off. I don't know what they're doing for graduation, all that. And I don't mean to like upset you in the morning, but I do apologize. And thank you for being here, showing up in the morning. Now is really a time like I told you guys when we first started this to give me feedback, and I got a lot of feedback. Tried to implement some that I could. Other stuff, for instance, like putting stuff in my wall, I kind of keep forgetting to do. Mostly because like I remember it every once in a while, but I'm just not good at that kind of stuff. Like as you can tell from my classroom, it's just not something I think about or am like very creative with. Like I don't know what I put on my wall. I don't know what I do. I don't know how I can make it look cool. It's not what I do. I need people around me to do it, but I'm in quarantine. I have no one around me to help. It's something like my mom would help me with or some of my friends, but can't really see them. So I'm on my own, and Mr. Harris on his own with this stuff isn't always great. So that was one of them I did get a lot of feedback on, though. And I agree. I think it would be cool if I could. I don't know what I would do. So yeah, if you have any advice on that. But if you guys have any input on anything, because now this is our reality, so now's really a time. If you guys have some suggestions, something that you don't like, something you do like, for me, I would really appreciate that. You can just email me or post in a Google Classroom. Just post a comment and just be like, hey, Mr. Harris, this is dumb. Why are we doing this? Or hey, Mr. Harris, I have a really good idea. What do you think? And we can run with it. So I wanted to remind you guys of that. All right. It's about 10:05. Looks like we got 10 people. Of course, smash the like button. I mean, hopefully at this point, this is just like second nature. You just pop in the stream, just smash it, move on, be ready to learn. I hope that's kind of like the way you're getting into this because I ask you every day. But It would mean a lot to a small, lowly streamer such as myself. So in terms of what we're doing today, you guys can see the calendar. I'm sure you've taken a look at it. We're gonna review at least a little bit. I'm not gonna go through the entire work, but I do want to review like maybe one part of Unit 5 FRQ, Part B. So let's actually start there if you guys want to get that open. Ideally, because we do have, today we're doing Unit 6 FRQ, and it's actually fairly long. So I do want to give us like plenty of time to do it, which is why, but I don't want to take too much time on this. But if you do guys have a quick question on Unit 5 FRQ Part B, we can do that. Ideally, Friday you guys come in and we can talk about it Friday. That would be ideal. So if possible, if there's something you really like that prohibited you from doing the assignment that you need to move forward, I would love to answer. Emma says 1C and 2D. Yes. Okay, 1C is actually good because 1C will take like a second. Oh, hey Sierra, this is calculus. Algebra 2 is 11 o'clock. Haber, yeah, 1C and then 2D. Yeah, okay. 2D should work too. So it's going to be a little hard just because, like, you know, everyone's at a different spot in the assignment. So, guys, open that up, and so hopefully you can follow along. I have it up right now. And actually, the first one, I don't even need to use my notebook. I'm just going to use my screen. No problem, Sierra. If you want to learn some calculus, stick around. But we're a little far into the year. It might be a little difficult to catch up. Okay, so you guys should be able to see on my screen now 1C. So let's start there. It says fill in the missing entries in the table below to describe the behavior of G prime, G double prime on the interval -3 to 3. Good morning, Alexis. Indicate positive or negative. Give reasons for your answers. Okay. So you can see where this is coming from all stems from the graph up here. Okay, so if this is G, what do we need to know? So first of all, let's remember this. Okay, crucial part of this problem. What is G prime and G double prime signifying? Well, G prime is the derivative, which is the slope of the tangent line, which means that what is the slope of the graph, essentially? What's happening at each point of the graph? Are we increasing or decreasing? That's what a derivative is saying. It's telling us, is it increasing or is our original function increasing or decreasing? G double prime is telling us concavity. Where is it concave up? Where is it concave down? Okay, so we go back down here and it says fill in the missing. So from -3 to 0, let's check the derivative. In other words, is it increasing? -3 to 0. Is this graph increasing? Yeah, looks to me it is. So that would be positive. Your derivative would be positive. Positive correlates with increasing. How about from 0 to 3? Is this function increasing? Yep. As x gets bigger, y gets bigger. So it's increasing, meaning that is a positive derivative. Okay, back down to the table. The second derivative. Okay, so let's look at concavity in the exact same intervals. So looking from -3 to 0, this concavity. Like I said, you're always looking to see, is it like an open bowl? Or is it almost like something is enclosing area? I guess that's kind of how I look at it. So you can see from here, right? If I were to pour water in, it would fill in here. I mean, I know this curve isn't like up, but if I were to pour water down it, it would fill in right here. So I think of that as concave up. All right, it's like it could hold something that would be concave up. That's how I kind of picture it. So that would mean that if it's concave up, the second derivative is positive. So from -3 to 0, G double prime is positive. From 0 to 3, if I were to like pour water down here, it's just going to fall right off. Okay, it's just going to fall right off and fall all the way down here into the concave up part. So this would be concave down. All right. Another way you can look at it is if you see that there's the derivative is small and then big, it's concave up, big and then small is concave down. So this would be a negative G double prime from 0 to 3. And we call the point at 0 and the inflection point. That's where it changes concavity. Okay, so that should answer 1C. Let's look at 2D. (2D) looks like a lot of words, looks really complicated. It actually turns out to be not too bad. So it says for 0 to 18, the number of bats in the field is modeled by the differentiable function b, where b is a function of the number of mosquitoes. So let me switch over to my... Okay, so this is Unit 5, Part B, 2D. Okay, so first things first, the number of bats is a function of the number of mosquitoes. That's called the composite function, the function of. The function of a function is a composite function. We represent composite functions as, in this case, the outer function is b, so b of m of t. Okay, so you needed to get that. That had to be the first step. Okay, now, in this case, sorry, it shouldn't be m of t, it should be m of a. Apologize for that. Because they say t equals a. So we're not using t, we're using a. Okay, so now from here it says we want to, based on the models, write an expression for the rate of change of the number of bats. Okay, so if this is the number of bats, this function b of m of a represents the number of bats at time a. The rate of change of the number of bats is what we call a derivative, b prime of m of a. Now, here's the big key, though. If we're finding the derivative of the original function, b of m of a, so we're finding the derivative. This is called a composite function, meaning it's chain rule. So we take the derivative of the entire function, so the derivative of b of m of a, which is b prime of m of a, multiplied by the derivative of m of a, which we call m prime of a. So I think that concept confuses a lot of people, using a chain rule with a function that's just we don't actually have values for, it's just generic. So you always take the outer function derivative, so the derivative of b is b prime, the inner function always stays the same, multiplied by the derivative of the inner function, so m prime of a. Okay, and then to finish the problem off, we're going to just rewrite this and fill in the values. So I still have b prime, because I don't know what b is. I know what m of a is, though. It's negative a cubed plus 12a squared plus 144a times, I know what m prime is as well. It's negative 3a squared plus 24a plus 144. So that's your final answer. That's the expression. Because the question asked you just to write an expression for the rate of change in the number of bats in the field. That's the best we can do. Anyone have questions? Haver, you good on that? Any questions on that? The patented Emma Haver's thumbs up. Awesome. I'm glad you asked for 2D, because I think that was definitely going to be people's questions. Good, that was easy. Yeah. Welcome to calculus, Jasmine. It's funny you say that, because I have BC. Students say it all the time. Like they'll be doing a problem and they'll just be like, wow, I way overthought that. And that's what I want you guys to, that's why I'm doing so many of these FRQ reviews. And I know it's obnoxious, but that's what I really want you guys to be careful of. Like, I want to make sure that you're not overthinking things. And, you've seen actually, we've done a problem like that before in this year. I don't remember what assignment it was, but unless I'm thinking BC, sometimes I get those two. Sometimes your classes I get combined. But either way, you can see these now, and then if you have it on the AP test, you're like, oh, I remember doing that, and I remember it was easier than I thought it was going to be. So that's kind of what I'm hoping to expose you to as many types of questions as I can. So then when you see them, you don't like think it's like a really, really complicated thing when it takes like a minute. Okay, so I want you guys to turn, or to bring open, I should say, pull up the Unit 6 FRQ Part A. So I have it on my screen right here. Get that opened up and then let me know when you're ready. So this is Unit 6 FRQ A. And I want to do this just to kind of break up a little bit of the monotony of me just talking the whole time. I want to give you guys an opportunity to try to do some, I started off with these FRQs because we hadn't seen that many of them. So I was like, okay, I'll kind of walk you through it, hold your hand through them. And during our lecture, and I'll give you kind of the answers, and I'll be very, very specific, and you guys kind of just copy my work and ask questions. Today I want to do it a little bit differently for some of the parts. So for the parts where I'm pretty confident that you guys can get, or I guess maybe my expectation would be that you would get with not too many issues, I want you to do those problems. And then there's going to be certain parts of this assignment where I'm like, okay, I got to probably step in because it's a little bit more complex or it's something we haven't really covered enough. So I want to start off with number 1. I want you guys to do 1A. So I want you to do 1A, and I want you to put your answer in the chat. So I'm not even gonna get you started. I just want you to read the question. Not too long of a question. They give you a table. Based off that information, I want you guys to get an answer for 1A. And then once I feel like most people have put in their answer, I'll go over it. So I'll give you guys like 10:21, 10:22, about 3 minutes to do this. Just 1A. Don't forget, guys, put your answer into the chat so I can see, get some feedback who's done the problem, if you guys got through it. Thank you, Alexis. Make sure, too, I want to see units. So it says indicate units of measure. That's really important as well. So when you guys put that in your answer, also give me the units. Thank you, Haber. Awesome. Awesome. All right, so that's about it. So if you're doing this problem right now and you still haven't gotten an answer, I think that would be about 3 minutes is all you would need for this, that's as long as you'd want to take on this part, and that's probably even more long. It's probably longer than you'd want to take. So if you haven't gotten this answer yet, we got to try to pick up the speed a little bit on that. So let's look at what this question's asking. So the question says they give you a table. They say this is the rate at which water leaks from a container. R of t is measured in gallons per hour. So you guys notice that this function is already a rate. So straight up R of t is a rate of change. Okay, so that's going to be an important piece to understand. And they give you the values, whatever. So it says use the data in the table to approximate R prime. Whenever you're approximating derivative, you are always taking an average rate of change, or the slope of a secant line, no matter what. Whenever you're approximating a derivative, you are taking average rates of change. Okay, and so our best estimate, our best approximation is whatever splits 1/2, or whatever 1/2 splits is what I should say. So our table only gives us 0, 1/3, 2/3, and 1. 1/2 lies between 1/3 and 2/3. So if we want to approximate it, we find the slope between 2/3 and 1/3. Slope is y2 minus y1 over x2 minus x1. So r of 2/3, r of 1/3, 2/3 minus 1/3. Okay, and we know these values. They're in the table. So it's 5 minus 8 over 1/3. That equals -9. Okay, now the units of measure is probably the hardest part of the question, because you had to understand that if R of t was gallons per hour, then when you take the derivative, it's going to be gallons per hour per hour. So we call that gallons per hour squared. So you're basically just adding on another time unit. All right, so that was your answer for part A. -9 gallons per hour squared. So good job, those of you guys got that. All right, let's look at part B. Same thing, I want you guys to try part B. So get started on that. I'm going to give you 5 minutes to do it. Okay, guys, about a minute or two left. Go ahead and post your answer to the chat when you got it. Make sure you include the units. All right, I'm going to go over this now. So my intention of why I'm kind of timing this for you guys, just so you get a sense of how the time for the actual AP test is going to go. Okay, you have 15 minutes for one question and 25 for the other. So right now, the way I'm pacing this one is about 15 minutes. All right, so again, this is the same thing. If you haven't gotten this question done by this point, it means you're going a little bit slow. And that's okay. I'm not trying to like make you feel bad or pressure you. I'm just trying to keep you on a pace that's going to be good. So we have to be able to identify the question quickly and start working on it quickly to get an answer. So here's how like my head's approaching this, so you guys can kind of get in the mind of like when I look at this question. Okay, first things first, left Riemann sum. All right, right off the bat, that's huge. Okay, when it says left, it means it's left endpoint. Riemann sum is when I know when I have widths, when I'm making rectangles, is what it is. I'm making rectangles inside, so I'm going to have a width times a height, and I'm going to add those up, and that's going to give me my left Riemann sum. Okay, so you're getting all these pieces together, and then we're using it to approximate this integral. You don't really need to understand what this integral means. All you really need to understand is you're finding a left Riemann sum. That's really all you need. But understand that this is the definition. I mean, a way to approximate an integral is by using using Riemann sums. So what I want to do is they say to use this interval from 0 to 1. So you guys can see on my screen, that's my table. I need to use 3 intervals. So 0 to 1/3, 1/3 to 2/3, and 2/3 to 1. That's 3 intervals. Each of those intervals would have a width of 1/3, which is nice because I only have to use that. I only have to use 1/3 as my width. My height of each endpoint. Okay, that's the key. So for B, it says it wants us to use left Riemann sum. So that means I'm going to have left endpoints, which means I start at the beginning of my interval. So I need to find, not F, what R of 0 is, and then move down the line. I should have 3 endpoints because I have 3 subintervals. So then I'd find the next 3 endpoints. So 0 is my first left endpoint. Then I go to 1/3, and then I go to 2/3. So let me flip over to my notebook. So that each of my rectangle, the height's going to be 1/3, or the width's going to be 1/3. To find each height of each endpoint, I need to find the function value at those 3 points, which I know. They give that answer to me. It's 11, 8, and 5. So we put this together, and my final answer of my approximation for that integral is going to be my width, which is 1/3, and you could do this separately, but I'm just going to multiply 1/3 times everything because every width is 1/3. It's going to be 1/3 times 11 plus 8 plus 5. And you get the answer of 8. Now, it says use units of measure. If you're taking the derivative, if you're taking the integral of R of t, well, R of t is measured in gallons per hour, which means that the integral of gallons per hour gets me back to just gallons. So my unit is 8 gallons, right? Because this R of t is gallons per hour, so the integral is just going to go back to gallons. The derivative would be gallons per hour squared. So you guys can kind of see how those units stack up. Any questions on that? I don't know how delayed I am, so if you guys don't have any questions, give me a thumbs up so I know you're not just ignoring me. Cool. All right. Okay. I'm going to do 1C. So we'll do this one together. Oh, wait, Andrew had a question. Sorry, Andrew. What does the first part of the answer mean? R of t dt. First part of the answer mean. Oh, I'm assuming you meant this, Andrew, maybe? This integral from 0 to 1 of R of t dt just means the area under the R of t curve is what that's saying from the point 0 to 1. What's the area underneath the R of t curve? We can find that by using left Riemann sums. We can approximate that by doing that. So yeah, integral formation would be. Payne, we know it's gallons because R of t is gallons per hour. So whenever we kind of think of it, like I kind of think of it as like a scale. So if I'm going this way, I think R prime of t, which you'll notice I just add a time factor. Okay, so R prime of t is gallons per hour squared. And then if we were to go backwards, that's the same thing as like the integral of R of t. So if you notice, I'm adding time each step I go. I'm taking away time on each step I go back. So R squared turns to hours, turns to nothing. So that's where I get that the integral of R of t is just gallons. So this little map shows you the progression. Integral of R of t equals gallons. When you take the derivative of that, you get R of t, which is gallons per hour. And when you take the derivative of that, you get gallons per hour squared. That's kind of how I look at it. Okay, so part C. Not too bad. Part C is very quick, but you have to understand what the question's asking. So at the end of the day, this is all it's saying. It's saying what is the integral from 1 to 3 of R prime of t dt. That's what the question's asking. It says use a table to evaluate that. Keys. First of all, you know you shouldn't be doing a Riemann sum because it'll always tell you to use a Riemann sum if you're using one. If it never says it, then don't even just push it out of your brains. We're not using it. Which means that I think a lot of people's first temptation, because we don't have the function R, would be like, oh, I got to use a Riemann sum. Whenever you see an integral of a derivative, you have to be thinking first, or the fundamental theorem of calculus. I almost can guarantee, I can't guarantee, but I should say I'm very, very confident you're going to see the fundamental theorem of calculus on your AP test. Why? Because it's called the fundamental theorem of calculus. You would think that the fundamental theorem would appear on a test to test you on the course, right? That's how my mind's kind of working. So if you don't have a really strong hold in the fundamental theorem of calculus, make sure you guys review that. We did that more recently. But go back, try to look at your notes for that. So integral of a derivative, that's the fundamental theorem of calculus written all over it. Okay, and all that says is there's two parts. The first part we're ignoring, but we are going to look at the second part. The second part says if we have something in this form, that's going to be equal to the function value. So if this is r prime, just the function value of the first bound, 1/3, minus the function value of the lower bound. So the function value of the upper bound minus the function value of the lower bound. So that's what I get. That's by the fundamental theorem of calculus. So FTC, part 2. That's how I get there. Oh, you can't see that. All right, now that makes things kind of easy for us, or at least easier for us. All right, so what we need to decide is what are these values? Well, we look at the table. Okay, the table gave us these values. The table said that r of 1/3 was 8, r of 0 was 11. So my final answer is -3. That's a problem where they put on there because they think that it's going to like trip you up and it's going to take you like an hour to figure out. Because you're going to try too many things and you're going to get confused. But you can see it's all it is. It's just one theorem that gets us the answer. So I realize now I don't think I'm going to get through this whole assignment, which is okay. So we might have to do this. We might have to do this Friday, just so you guys are aware. So we might have to finish this up Friday. I won't make you do it for homework. You guys can just do your homework assignment. But if I forget, remind me Friday to finish this problem up. I'm going to make a note for myself so I shouldn't forget. But Payne, do we have to prove it's continuous or anything like that? No. No. For integrals or fundamental theorem of calculus, no need. Okay, so and the reason why I'm saying this is because D is a little bit of a doozy. Okay, this problem isn't the easiest in the world. So I'm going to walk through this kind of carefully. Hopefully 1A through C you guys have a pretty good understanding of. Hopefully that stuff wasn't too bad. Hopefully you looked at and you said, oh, I could probably do that on my own without any help. That's the goal. 1D though, I do understand this was kind of a little bit weird. Okay, we have the tools, but it's just a matter of being able to process them. Okay, so let me go over to my assignment here. This is what we're given. It says the sum from k equals 1 to n of r of 1/4 plus k over 2n times 1 over 2n is a right Riemann sum with n subintervals of equal length. The limit of this sum as n goes to infinity can be interpreted as a definite integral. Express the limit as a definite integral. Okay, so essentially what we're looking for is this. Looking for what is the limit as n approaches infinity. Oh, crap. I always forget. This is what we're essentially looking for. The limit as n approaches infinity of this summation. What does that equal? And what that equals is something in terms of an integral. That's what the problem tells us. So let's break this down. Break this down into pieces. Okay? So first of all, the summation, the right Riemann sum, which is this part. This is the right Riemann sum. Okay, we gotta pick some pieces of this. Remember, whenever we're having a summation notation, or whenever we're expressing a right Riemann sum or any Riemann sum in terms of a summation notation, it's going to be the height times the width. This r of 1/4 plus k over 2n represents the height of every single square or rectangle. This represents the width of every single rectangle. So we can also say my change in t, which is the same thing as width. So 1 over 2 of n. So like I said, I'm just breaking this up. So the two pieces, I know height and width. This is my width, so I'm just marking it down. However, we got to use this to help us get some other information. And that specific information we need is we need to know, okay, what's going to be our interval? Okay, because we want to express the limit as a definite integral. Well, guess what? Definite integrals have bounds, upper and lower bounds. So we have to decide what are our upper and lower bounds of this Riemann sum. Where do I start and where do I end? Okay, and to do that, we got to figure out what's my total interval. When is that? How do we find what the total interval is? And we can do that pretty easily, actually. We can do that when n is equal to 1. And here's why. Because if you guys look back at the question, it says the limit of the sum as n goes to infinity can be interpreted as a definite integral. N is the number of sub-intervals. So when we're making, if you guys picture, we're drawing our curve and we're making our rectangles. Our interval, what if, I guess here's my question to you. What if I just chose, you know what, let me just draw a picture. Maybe this will help. So that's my curve. Let's say that's my interval from A to B. What if I just had one subinterval? What if I just had one, right? Let me do it in black. It would look something like this. That would be one subinterval. That'd be like a right Riemann sum with one subinterval instead of n. And guess what? That gives me the entire length. One subinterval will give me the entire length of my Riemann sum, or whatever I'm approximating. So my total interval is when n equals 1, or when I only have one subinterval. So in this case, 1 over 2 times 1 gives me 1/2. That's my total interval, is 1/2. I know that my integral, my eventual integral, has to be a length of 1/2. So that's a really important piece. Now, I'm pretty sure, I don't know, again, this might have been BC. I don't know if you guys have seen this type of question. I thought maybe you had, but whenever, this is our total length. But if you guys notice, the original question gives us a table from 0 to 1. So 1/2 is in there, and we can use we can have a lot of different endpoints or bounds. We can have a lot of different bounds that'll be a length of 1/2 in between 0 and 1, right? We could do 1/4 and 3/4, which is what I'm going to do. And there's a bunch of other ones. But that's what, so my point is that you can choose any value. So choose any values from 0 to 1 that have a length of 1/2. And so what I'm going to do, like I said, is I'm going to choose the values 1/4 to 3/4. That just seemed like the easiest value for me to pick. So I'm kind of boxing this stuff in red because I know I'm going to need it. All this like writing isn't necessary. I'm just doing this to help you guys. I'm just doing it so when you guys look back at your notes and you're like, what the heck was I doing? If you write this down, it'll tell you exactly where you get some of this stuff from. So I can confirm this interval has a length of 1/2. So I can use that when I write my integral. Next piece I need, if you guys look back up here, is inside of the function. We talked about this as being I sub k when we were doing our problems with our summation notation, which represented our right endpoints. Or sorry, x sub I. I don't know what I was saying. X sub I is how we represented it. But the blue is our right endpoints. So essentially, whatever's inside that function gives us our right endpoints. So in our case, right, it's 1/4 plus k over 2n. Okay, now, actually, from here, we can actually get our answer. So I don't want to have to rewrite this whole thing. So I'm just going to draw an arrow. So this entire limit, we know this is the literal definition of an integral. Okay, so when I first taught you guys integrals, we used this definition. Because we started off with this, the red box. We started off with that. And we said, how can we express these Riemann sums in summation notation? And this is what we got to. We did this. And then I said, okay, well, what happens if we do an infinite number of rectangles? And then we looked at that, and then we decided, okay, well, if we're going to do an infinite number of rectangles, we can represent that by taking a limit as n approaches infinity. Because that's just going to, n is the number of subintervals, so if it goes to infinity, it's adding infinite subintervals. And so we said, okay, that's what it would look like. How do we express this easier so we don't have to keep writing that a million times? Okay, and then we eventually stumbled upon, oh, that's what we call an integral, or an integral. So, let's look at this. My upper and lower bound should be my range, or my interval. So 1/4 is my lower bound, 3/4 is my upper bound. This whole point is just summing the subintervals of R of t. It's approximating the area under the curve of R of t. So pretty easily put, all we do is we just say, okay, well, it's the integral from 1/4, 3/4 of R of t. So all that stuff to look at, all that work, all these different pieces just to find, that's what your answer is. So you guys can see the biggest step, even the part in the blue, I just wanted to point that out. Don't even really need it. Okay? The really important part is this in the red. The fact that the total length is 1/2, and then you just got to decide in that interval, what is it going to be? Yeah, absolutely, Payne. This question is like a super specific question. It's not something like I want to spend a ton of time on. But we always have to be careful. This could definitely be a good type of question they would ask. So yeah, we're gonna get through all the progress checks. So we'll get through all those. We're almost done already. I'm gonna go back afterwards and I'm gonna find other FRQs we can go over, and I'll look for something like this so we can get extra practice with it. Because I agree, this stuff isn't easy. It takes a lot of conceptual understanding. So I know it's not easy, and what stinks is like I'm not in class to like help you guys and walk around and try to get it. If you guys have any questions specifically right now, please ask them. It's really hard for me just to talk to like nothing and hope I'm making sense. So I don't really care if we spend the next 7 minutes talking about this. I'm not going to rush through the next part, but go ahead and chat. If you guys have a specific question that's confusing you, I'd love to hear it. Yeah, Payne, correct. Andrew, so in order to find the width in problems like these, would it be given at the end of the first limit like it was in the problem? So in order to find the width in problems like these, would it be given at the end of the first limit like it was in this problem? Yes, exactly. Not the first limit, the first summation. So let me go to my screen here. like Andrew, like right here. They might put it at the front, but the important thing is this. The width is always going to be like on its own. The height is always going to be a function value. So you always see like f of, or r of, or t of, whatever it may be. Yeah, exactly, Andrew. So you can always find the width. To find the specific interval, you want to take it when n is equal to 1. When there's only one subinterval, like I showed that picture to you guys earlier, if you're taking one subinterval, that's one rectangle. So the one rectangle is going to cover the entire width of the interval. So if we were kind of to like back up, basically like an original question for this could have been like, well, like you think about where this summation notation came from. Well, basically the question would have been like, hey, I have an interval of 1/4 to 3/4. Write a summation notation that expresses n subintervals. And this is what you would come up with. I'm kind of ranting. I don't want to confuse. I don't want to go any farther than that. But maybe someone out there understood what I meant. Good question, though. Yeah, I mean, at the end of the day, to really oversimplify this question, it's basically just asking you to find the bounds of that summation. And all that really entails is just finding the length of the interval. In this case, it's 1/2. And then once you get that information, all you have to do is take the integral of the function. So like that's oversimplifying it, but you can break the question down into that. And I'd actually rather not even start on 2. I'm gonna make a note right now for myself, so I have it. If you guys have any more questions on any part of this question, by the way, so including A through C, if you guys have any questions, you want to review any of that, go ahead now. I think now is a good time to stop, so we don't have to start a brand new problem. So make sure, guys, in your notes, give yourself another like 2 pages to go over part 2. So on Friday, I'm going to do part 2 for this, or we'll do part 2 instead of doing a review day. We'll just work. And I want you guys to give yourself plenty of room to write the work down. So give yourself like 2 extra pages before you start tonight's homework, because I think part B will take about 2 pages. Well, guys, if you have no other questions, I made a note for myself, so tune in on Friday. We'll finish this FRQ up for sure. That'll be the first thing we do Friday. So before we review any material, that's what I'll do. And then the rest of the time, you guys will have open to ask any questions you want. Like Peyton said, I want you guys to remember, I just want you to submit the assignments that are for homework. So those, you can submit it. I mean, I'm just not going to grade anyone's from class. So if you submit it and you're like, hey, Mr. Harris, I did this work and I just wanted you to check it, see if it looks good, let me know and I can go in and check it. But I'm only going to grade the assignments that are for homework. Because, again, the understanding is that you're here during the lecture, or you can watch the YouTube video, you can get all those answers. So yeah, first thing we'll do is part 2 on Friday, and then we'll do a review of anything during the week. I don't care if it was something we did in class. I don't care if it was homework, whatever. So make sure you guys come with a lot of questions on Friday. Okay, and if there's nothing else from you guys, I hope you have a great rest of your day. It was good seeing y'all, talking to y'all. See you Friday, 10 a.m. Oh, and I won't be here for office hours today. I won't have a live stream. I'll be available, so just email me. I can answer your emails, but I won't be available for a live stream. I have a meeting. So just email me if you have any questions today or tomorrow about any assignments. Thank you, Haber. You have a great day as well. Morning, Jaden. How are you? See you, Gidio. Have a good day. I'm doing pretty good, Jaden. Little bummed out, but I'm doing all right. How are you doing, Jaden? Not too bad. What'd you have for breakfast this morning, Jaden? Eggs and bacon? Nice. Hangman? Sure, we can do hangman. Who else is here, by the way, from Algebra? All right. Let's do it. Give me a topic, Jaden, or anyone. Hey, Damon, good to see you. Uh-oh, why is my screen black? There we go. Hey, Sierra, good to see you. I could tell you really wanted to learn some calculus today. Oh, let me see here. Yeah, all right, that's good enough. You can tell. All right, what kind of topic do I want to do? Let's see. Morning, Digidio. All right, I got one. Clothes. We're new clothes. All right. There you go. Hopefully I spelled this right. Spelling is not my strong suit. Nope, not pants. That'd be too easy, Jaden. Come on. I'm a little bit more creative than that. You're supposed to guess letters, Jaden. That's how that game works. I'm giving you body parts. You get a head, a body, and 2 arms for your guesses that were incorrect. That's I know it's a steep punishment, but I gotta play by the rules here. Hey, there we go. First letter is A. What else we got, people? Oh, good guess. I think there is an O. What else people got? There you go, Sierra with the win. I realized when I had it was a really good word at first, but then when I realized it starts with an A, it kind of I'm like, oh, that's gonna be one of the first things I guess. And then there's not very many clothes that start with an A, as far as I know. Well done, Sierra. Apron. Why did I think about that? I don't know. I don't even know an apron. That's what's going through my head. Woohoo! Hey, congratulations, Sierra. You get a bonus point. Not actually, but in my head you do. All right. So I think everyone should probably be in here who's going to be in here. So let's see. I have Digidio, Sierra, Jaden, Damon. Okay, so I know at least I have 4 of you. So let's start off with the sad news. Okay, and the sad news being that we will not be back at school. So if you guys haven't heard, no, we will not be back. Aprons are closed, Jaden. What are you? Okay, before I even get into that, what aprons aren't closed? What? What do you define as clothes? I could walk outside with an apron on. That would be considered clothing. People wear them to protect their clothes from getting stuff on them, true, but you could wear an apron. If you can wear something, wouldn't that be a piece of clothing? It's stitched together, right? I don't know. I'm actually asking now because now you got me thinking. Sierra says yes. Yeah, an apron is a protective piece of clothing. Jaden. Apron is a protective piece of clothing made from fabric that covers the front of the body. Some workers wear aprons for hygienic reasons. Aprons can be made from any materials. That's a good point, Jaden. That's a good counter argument. But then again, I don't know. No, I guess you're right. Yeah, it's not. But clothing is, I think, made to cover your body, right? Some sort of cloth or fabric that covers your body. That's how I think of clothing. An apron does do that. It's a protective piece of clothing, right? It covers your body. A garment would be another word for it. I do like your argument, though. Your argument my original argument was not very good, and you kind of just proved that with the watch. point. But I think this definition makes it pretty clear. It's definitely clothing. All right, that was important. Very glad we got that settled. Okay, because that was a hot debate right there. All right. So today, first of all, guys, go ahead and smash that like button. My likes have been pitiful. And as an up-and-coming streamer such as myself, it's hard for me to keep the lights on at home without you guys giving me those likes. Much appreciated. Yeah, Damon. That's what I was gonna get into. Good transition from Damon. Ooh, I whistled. I don't know if I can do it again. Very good transition. Back to the whole school discussion. This is weird. All right. If you guys haven't heard, I'm sure most of you have. But if you haven't, oddly enough, I haven't heard much feedback from it. I thought I was gonna get emails and calls and all this stuff. I thought everyone was going crazy. I haven't heard really anything from anyone about it. But I mean, from my understanding, Mike DeWine went on TV and he basically said schools are shut down for the school year, not the whole year, the school year. So for the rest of the 2020 school year, we will not be in school, which is very, very disappointing. And it makes me a little bit sad. So a downside is you guys won't get to see each other in school for the rest of the year. I don't get to see you guys. You guys don't get to see me, which probably a lot of you are celebrating. But, it's sad. We don't get to be in that environment. I know when you're there sometimes you kind of are miserable and hate it. But at the end of the day, especially when you don't have something, you kind of you realize how much it actually, you enjoy it or how much it means to you. So yeah, that stinks. And I think what I said to Calculus, and I'll say to you guys, is I was kind of a big part of, I think, the motivation for some people and just the overall positive energy, I guess, for a lot of people was the idea that we were eventually going to get back in school. It started off where it was just okay, we'll be back. Yeah, right, Michael? I just had a conversation with my parents about that. Weirdest first year of a teacher of all time. But I was kind of thinking to myself, when we first started, when this all happened, it was all just really quick, sudden, weird, people scrambling. But we were just saying, okay, spring break, we'll be back. So after spring break, it was we'll be good. No issues. And that was everyone's intention. So we kind of got used to this whole online school thing. And we're this is good, we're going to make this work. And then when spring break's over, we'll be back and see everyone. We'll be happy. It's like a nice little break, and then we'll be back in school. Okay, now, after that, we were he came out and said, no, May 1st. And then we're great. All right, so now we got to wait till May 1st. And then still there was some tweets from the president, other people kind of excited, oh, we'll get back to life May 1st. And then that was our date. And then obviously he came out, I think it was Monday. Yeah, Monday. He addressed it and he's nope, schools, that was the first thing he talked about, schools will be canceled for the rest of the year. So I guess the plus side is the fact that we get the information. So now we know we don't have to wait till May 1st to get shut down again. Now we know right now it's not happening. We're not going back to school. Okay, so now we can mentally prepare ourselves. Why am I talking about this? Well, first I'm talking about it because I'm sad. I'd like to talk to you guys about it. I hope you guys are doing well. First and foremost, hopefully mentally you guys are doing okay and health-wise, right? I know this is not easy for certain people. Some people, this is their dream. This is what they wanted all along, right? Online school, perfect. People are this is the best thing that's ever happened. I get to play video games the majority of the day. I can procrastinate my assignments, do them last minute, and I'm done. It's fantastic. That's some people's mindset, and good for those type of people. Honestly, I probably would have been that type of person too. I probably would have been completely okay with it. Besides the fact you don't get to see your friends and stuff, that stinks. But in terms of schoolwork, this would have been right up my alley, this whole situation. Other people don't know. Other people, and a lot of, especially you guys, I got to assume the 8 of you who are in here right now are choosing to be here. Or your parents are making you. It's probably one or the other. But regardless of your motivation, I think this kind of setting has a benefit. I know it's not exact, but this is as close as I can do to like treat this as a normal class, right? A lot of people benefit from me, not me, but teachers in general, helping them in class, being in person, having that face-to-face interaction, you know, just kind of that environment in general is very conducive to learning, and that really is important to people. So for those types of people, this is hard. This is really difficult. And I know it's been really hard on your mental stability, right? Not being outside, not seeing your friends, playing video games all day, not maybe necessarily eating healthy. There's all sorts of factors that go into it, not getting exercise, and it's weighing on people. So I'm hoping you guys, now this realization has come upon us. I don't want anyone to panic. I don't want anyone to get stressed out and to like freak out about it. We're gonna be okay. Luckily, in this class, I don't know how all your other classes are, but I can say pretty definitively with this class, we have a schedule now. We have a process. I think you guys are all getting a hang of it, and I think you're doing a very, very, very good job. So hopefully this class, at the very least, is a little bit less stress on you, and you can, it's predictable. You know what's going to happen. You know what you're going to get, and I hope that helps. Make sure you guys, now that this, like I said, now that this is happening, start creating a schedule. Like get on a routine. Okay, I think like I said originally, it was all short term, so you didn't really need to get in a routine. You kind of just like fought through it and just said, I'm gonna suck it up. If I'm not sleeping very much or I'm not doing my work, it's fine. I'm gonna be back in school in no time, and I'll get back on like the school schedule. That's not happening. So you guys have over a month, about a month and a half, maybe a little less than a month and a half left of school, for you to find a schedule that works for you, and that'll keep you involved, keep you motivated to do schoolwork, and also to do all your other stuff. If you're playing a sport, to practice for your sport. If not, just in general, go for a walk with your dog or your mom or dad or something for 30 minutes. Go do push-ups or sit-ups or jumping jacks. Swing a golf club. Whatever it is that gets you out of the house and gets you moving and motivated. So I want you guys to really, I think it's important you do that. If you find yourself you're getting in really bad habits of staying up till 6 a.m. in the morning every day, not doing any of your work, not just watching Netflix all day, like I know, like, as teachers and as our school in general has been pretty forgiving with you guys about this whole situation because it is crazy. But at the end of the day, now is a pretty good time to say, like, hey, I might as well get some learning in. Like, what else do you have to do? I mean, honestly, like, you have nothing better to do. I know maybe video games is something you enjoy, or watching TV is something you enjoy, but playing on your phone, going on social media, whatever. But none of that stuff's bettering you, At least with the schoolwork, you can prepare yourself for next year. So get the information you need for next year. So next year you're not going into classes like, oh, I know nothing. This is not good. Get you prepared for that. It keeps your mind active, thinking about something other than, shooting people on a video game or liking puppy pictures on Instagram. It gets you out of that kind of momentum and kind of makes you think a little bit and makes your brain sweat. And I don't know, I think that's important. So, I'm talking to you guys because you guys are here, which says a lot, which means that you guys are following that. So anyways, I'm kind of ranting a little bit. Just wanted to talk about it, and I don't have anyone to talk about it with because I'm by myself. So figured, and I can't see you guys, so figured I'd bring it up, kind of address it. We're going to keep doing what we're doing. So luckily we have a good setup, and we're going to keep going. But I will say, earlier on I had a survey. It was pretty early on with this streaming and everything. Mr. Sarah says this now, but after he's playing Animal Crossing, right, Michael? I'm telling you guys, like, stop doing all this, like, get your minds right. And then the second my stream shuts down, I'm in my PJs and I'm playing Animal Crossing till 2 a.m. You caught me, Michael. What can I say? You caught me. No, but I want to say, though, if you guys have anything you want to talk to me about in terms of the class, or if you're just really struggling in general, and you're like, Mr. Harris, like, I need some help or whatever, just let me know. And if you guys have any suggestions, I know I did a survey earlier on in this process, but now it's been a couple weeks. Probably, has it been almost a month, I'd say? Maybe it has been a month. It's been a little bit of time. I think it's been about a month we've been doing this. So if you guys have suggestions, if you're like, Mr. Harris, I have a really good idea, I think we should try it, email it to me. Let me know. Or post it in the Google Classroom so I can see it. Like, I'm open to suggestions. I'm open to anything maybe other classes are doing that you guys really like. I tried to take the results from the survey and I tried to implement them as much as I could. The one I didn't was like the decorations. I got that a lot like on my wall, but Mr. Harris just isn't a very decorative guy, as you can tell from my classroom. It's like pulling teeth if you're asking me to decorate. Just not who I am, not how I roll. So I usually need people to like do that for me or motivate me to do it or help me with it, and I'm by myself, so I don't have anyone to do that with. So I haven't really gotten on that. That's something I would take suggestions. If you guys find something on Amazon and you're like, hey, Mr. Harris, and this would be really good on your wall, go ahead and email it to me, and then maybe I'll put that up for you. But I need some suggestions because I just frankly won't do it my own. Yeah, so anyways, keep that in mind. But I appreciate you guys being here. So anything you guys want to add in the chat? Any questions you have? Comments? Concerns? Speak now. Joe Exotic. Oh gosh. Please no, Michael. I'm not a supporter of that man. Let me make that clear. Although I will say I watched the documentary and I'll say it was entertaining. Sometimes I feel guilty because those were not good people. Not good people at all. Don't be like those people. Horrible, horrible people. And terrible, terrible situations for those animals. Which is really sad. So I don't really support the people in the documentary, but it was a very well done documentary. So I will not be sporting any Joe Exotic posters. Now, the one guy who got his arm bit off, he was pretty cool. He seemed like he had a pretty good head on his shoulders, so maybe like someone like that I'd be more willing to. Can we go over a question or two on 8.1 study guide? Jared, getting right to it. Love the energy there. Love it. Yeah, we're going to get into that, actually. And actually, you're ahead of the schedule because we were supposed to start 8.1 study guide now, so maybe you've already started on it. I'm going to do that. That'll be what we do today during class. Did you watch The Last Dance? Oh, yeah, Michael, come on. You know I watched The Last Dance. For those of you who don't know, maybe some of you are interested and you didn't hear about it, but The Last Dance is a Michael Jordan documentary. It's like a 10-part documentary every Sunday. And so this past Sunday was the first 2 episodes, and it was fantastic. I can't wait for this Sunday. That's like something I'm definitely looking forward to every week. But I'm a big North Carolina Tar Heel fan, Michael, so that was Michael Jordan's kind of the man. So I have to watch that kind of stuff. You know I love basketball. All right. Okay, I'll keep checking the chat, but if we are good, Jared had a great idea. We are going to talk about 8.1 study guide. So guys, I posted to Google Classroom the 8.1 study guide, so go ahead, everyone get that up and open. And I'm going to put up my face and the screen so you can see what this looks like. So it looks like this, 8.1 study guide intervention. Michael, of course, I'm a Kentucky Wildcat fan. At least it's not Duke. I don't mind that. I can support Kentucky. I just can't support Duke. If you're a Duke fan, get out my face. Blue Bloods, Michael. We're Blue Bloods. Yeah, I've always been since I was like very little, I've always been a North Carolina fan. It all started with Ty Lawson. Well, actually, it really started with Sean May, which probably none of you know who that is. He was the first North Carolina Tar Heel fan I loved. And they beat Illinois in the national championship in like 2004 or something. 2005, like very, very early. And Sean May was their best player. He ended up playing for the Charlotte Bobcats in the NBA. And I used to love him. And I love North Carolina because they won me March Madness. My very first March Madness bracket I ever did, North Carolina won me. It was me against my mom. She had Illinois, I had North Carolina, and I won because of North Carolina. And my mom bought me a hat. That was the deal. Whoever won got an Illinois hat or a North Carolina hat. And so North Carolina won, so I got a hat. And yeah, It was pretty cool. So ever since then, I was like, oh, North Carolina's awesome. And then I like Tyler Hansborough, Ty Lawson, those guys. Rajon Rondo, yeah, he was sick. Okay, so let's get started. I don't want to rant on basketball because I know most of you don't care. So let's look at the study guide. And so what I'm going to do, I know, Jared, you asked for page 2, and I'll get to page 2, or page 6, I guess it would be, but the second part of this, right? I'm going to start, what I'm going to do, I'm going to go over a couple questions on number 5, and then we'll get to page 6. So just so you guys know, this is the plan, 8.1 study guide. We're going to do the evens. We're not going to do all of them. I'm just going to get through as much as I can before 12 o'clock hits. And then for homework, I already put this assignment in Google Classroom. You guys are going to do the odds. So all of the odds. So this is going to be pretty good practice. I don't think it's going to take you too much time, which is why I was able to assign, I thought, the whole thing to you. Yeah, okay. Well, that's 1, 2, 3, 4, 5. Yeah, okay, that's fine. I was just making sure it wasn't like too many problems because like looking at it, I was like, wait, that actually is kind of a lot, but it's not too bad. Okay, let's go to let's just do number 2. So guys, nothing new. Like I'm not, I have nothing new to give you. No new information today. Today is just a day for us to practice, and I want you 8 people or 9 people, kind of fluctuates. I want to get some feedback from you guys. So I want to see how you're understanding it, if you guys are doing okay, if you need any help with it, and give me some feedback. So let's look at, this is going to be 8.1 study guide. Number 2. This is page 5. You can see on my screen it's page 5. They give you examples, which is really nice. So I'm sure you guys know this. You can't miss it. But whenever you guys look at these study guides, the really nice part is they give you all the information you need. So like they give you an example of simplifying polynomials that are just one term, how to do that. It gives you examples of when you're multiplying polynomials, how to do that. And then when you have quadratics, how to do that. So it's really, like, to me, I think it's pretty cool. It gives you everything you guys, all the different types of questions you guys will see. I think that helps a lot. So let's start with number 2. 2 says we have 4x squared minus 12x plus 9 divided by 9 minus 6x. This marker's dead. Oh, I hit my TV. That was stupid. Oh well. Should not have done that. Oh, you guys just saw it too. That was not smart. Oh, well, I think my TV will be all right. All right, there's my number 2. 4x squared minus 12x plus 9 divided by 9 minus 6x. So the question says to simplify the expression. So we got, big thing to notice, a quadratic in the numerator, right? It's x squared, so that's going to be a quadratic in the numerator, and then just a normal linear function down at the denominator. So we want to treat these separately. We want to first look at it like, if you guys want to, you can do this as well. We want to first do the numerator and simplify that, and then we'll do the denominator. You can do this all at once. You can write them separately, whatever you want to do. It's up to you. I want to factor the numerator. So guys, whenever a, meaning the coefficient in front of x squared, whenever that isn't 1, we want to use our x box as a way to factor. All right, so we look at our x box, and we do a times c, so 4 times 9 is 36. Put that up top. And then b is negative 12. So we put that in the bottom. And we need to find 2 numbers that multiplied in 36 add to negative 12. Those 2 numbers are negative 6 and negative 6. If you're asking me how I figured that out, I know I can do it in my head, but you guys will have your calculators too. However you go about doing it, but You want to take 36 and find the factors of 36. So 12 and 3, 1 and 36, 6 and 6. I think that's 9 and 4. All right, so those are all the factors of 36. We just got to pick two that add to negative 12. So you just, in your head, kind of go through and try to get that answer. Hopefully we're okay with that. And so what we're left with then is we want to use our grouping. So 5x squared minus 6x minus 6x plus 9. We could, I'm using grouping right now. I guess maybe I think most of you probably use the window. But this will be good. You know, let's do this. I think this will be good. So this is showing you grouping. All you do with grouping is you take the first term, so that 4x squared. You take one of the sides, which in this case is negative 6, so negative 6x. And you take the other one, so minus another 6x, and then plus the last term, so plus 9. And then we call it grouping because we group them into 2's. So we group them as 4x squared minus 6x times negative 6x plus 9. It's not really times, but it's just grouping them, just separating them. And then you just factor the first one. So the GCF of 4x squared and 6x is 2x. And I'm left with 2x minus 3. And then the GCF here would be negative 3. So I'm left with 2x minus 3. Again, this is exactly what you do with your window. If you guys did a window, it's the same answer. Just I'm going to use grouping right now. So your final answer ends up being 2x minus 3 times 2x minus 3. The denominator is pretty easy. You just take the greatest common factor between 9 and negative 6x. So that's going to be negative 3. And you get, I'm going to switch these around. So negative 6x divided by negative 3 is 2x. And then 9 divided by negative 3 is negative 3. So let's go back to the beginning. My numerator factored into 2x minus 3 times 2x minus 3. Denominator factored into negative 3 times 2x minus 3. You guys notice that 2x minus 3 is the same in the numerator and denominator. So I can cross one of those out. And I'm left with 2x minus 3 divided by negative 3. All right, so take a look at that. Let me know what you guys think. If you have any questions, let me know. Sierra says good. Michael says good. Haley says good. All right, cool. Very cool. Are you guys good with factoring? Just in your humble opinion. How do you guys feel about factoring quadratics? Or just factoring in general, taking out GCF? How do you guys feel about that? It's really, really important for every math you do from here on out. It's a skill I really want us to get good at. Decent. Okay. Yeah. So I'm guessing the yeses are you're good at it. Good. Okay. It's a really important skill, like I said. So a lot of you, if not all of you, will be taking a math next year. So really want to make sure we're okay with factoring. Okay, let's try another one. Let's do number 8. I'm not going to write, actually I am. Okay, so I'll start us off on number 8 and then actually want you guys to try. So this is going to be a good challenge problem for you. So we're going to start off, the very first step is we have to write it correctly. If you guys notice, for 8, it has a fraction divided by another fraction. We never divide fractions. We always multiply by reciprocals. Right? So when I'm writing this out, I need to rewrite it so it's no longer dividing fractions, it's multiplying by reciprocals. So I take the first fraction, 16p squared minus 8p plus 1 divided by 14p to the fourth multiplied by 7p to the fifth, because that's the reciprocal. Take the denominator, move it up to the numerator. Divided by 4p squared plus 7p minus 2. All right, so most of you guys said you're decent or better at factoring. Well, this problem's gonna put you to the test. Okay, so what I want you guys to do is to factor everything here. So before you multiply them, you guys can go through and actually solve it if you'd like. But what I'm more curious about, at least to start, is I want you guys to just take the next couple minutes and I want you to factor this. So factor this entire expression. Simplify it as much as you can by factoring. Okay, so I'm going to let you guys go on your own. And then in chat, I want you to tell me when you're done or stuck. We'll see how good you 7 really are. All right, Michael, you want to be careful. I think I know where you're factoring, but I don't think you're factoring correctly. Because these two spots don't have a GCF. You have to factor by using your X box. All right, Sierra, you got through it. All right, we'll check your work. All right. Jaden looks like got the exact same answer. Okay. Give it a couple more minutes to see. Make sure, guys, please at least let me know if you're done. Don't have to necessarily type in your answer, but if just let me know if you're done or if you're stuck, so I know when I can go over it. Thank you, Jared. See, that's what I'm talking about. I think other people are too, Jared, but everyone's too shy to say it. I'm not going to be upset, just disappointed is all. Some argue is worse than being upset, though. I forgot how to do it. Jared, I just went over an example. Yeah, short-term memory loss, Jared. I'm just kidding. That's fine. Okay. I think that should be. I mean, I got at least. Well, how many? 5 of you guys. All right. So let's go from here. Okay. So, uh, whenever we're simplifying, okay, we always want to factor out GCFs if there are GCFs, or we want to factor using just our Xbox, our factoring, tools we've done before. So in this case, let's look at this first example. Okay, I want to definitely these two quadratics, so this one and this one. I want to make sure that these two quadratics I factor. So I'm going to start with, I drew an arrow, I'm going to start with just the first numerator. So I'm making my Xbox, a times c, 16 times 1 is 16. My b term is negative 8. What adds to negative 8 and multiplies to 16? Negative 4 and negative 4. Okay, now from here, you guys could do grouping or window, whatever you chose to do. I'm just going to make my window. Should have given myself more room, but I didn't. Top left, you put your first term, so 16p squared. Bottom right, you put your last term, so 1. On the bottom left and top right, you put your side terms. Now remember, these should have a p on them. Always got to keep the variable. It's a common mistake people make. Okay, so what multiplies to 16p squared and negative 4p? Well, negative 4p does. Negative 4p times what gives me 16p squared? Negative 4p. Negative 4p times 1 gives me negative 4p, and negative 4p times 1 gives me negative 4p. So I'm left with negative 4p plus 1 times negative 4p plus 1. That's all review. Everything I just did there was all review from earlier in the year. Okay, now let's do the other quadratic. So 4p squared plus 7p minus 2. All right, a times c, 4 times negative 2 is negative 8. My middle term is 7. What multiplies to negative 8 and adds to 7? Positive 8 and negative 1. Make my window. Top left, I have 4p squared. Bottom right, I have negative 2. Other corners, I have the two values I just found. So 8p and negative p. What's the greatest common factor between 4p squared and negative p? It depends on what you want to choose. I'm going to choose a negative p. Negative p times negative 4p gives me positive 4p squared. Negative 4p times negative 2, just times negative 2, gives me positive 8p. And then negative 2 times 1 gives me negative 2. So I'm filling out my, my window there. And so my factor is negative p minus 2 times negative 4p plus 1. All right. Now let's put all of these together. So the blue is going to be now negative 4p plus 1 times negative 4p plus 1 divided by 14p to the 4th times 7p to the 5th divided by negative p minus 2 times negative 4p plus 1. Move this up a little bit so you guys can see it. So I replaced the red and the blue with the actual factored forms. And now you can see I can start canceling at least something. Okay, I can cancel a negative 4p plus 1. And I can also cancel some stuff with these. Okay, so 7 turns into 1, and 14 will turn into 2. Right, because 7 divided by 14 is 1/2. P to the 5th divided by p to the 4th, this is 4 p's, this is 5 p's, so I'm left with just 1 p in the numerator. So my final answer ends up being negative 4p plus 1 times p divided by 2 times negative p minus 2. You guys look like your answers are correct. But you guys the numerator, you guys actually distributed the p, which is fine. Very good job. How was that? Give me some feedback. Was that easy? Hard? Make sense? Make no sense? It was in the middle? Okay. All right. So that means that you're probably not the hardest thing you've ever done, but it's also not readily oh, this is simple. I can do this in my sleep. Gotcha. Okay. So what I want to do is the next page. Oh, man. Give me a second. I got to reload it. So, Jared, this is going to answer, this is going to be page 6. This will help, this will answer Jared's question. So, guys, here's the thing. This second page, page 6, is the exact same thing as page 5. With only one tiny, tiny difference. So let's see what question I would like to do. Let's do hold up. Let's do 6. So number 6, guys, right here. Now, biggest thing, the only difference between this page and the page we were just doing is how we write this beginning. So you guys can see it's called a complex fraction. It is a fraction underneath a fraction. This is the same thing as saying a squared minus 16 divided by a plus 2 divided by a squared plus 3a minus 4 divided by a squared plus a minus 2. So what I mean by that is that we can rewrite this as instead of dividing this fraction by this fraction, we multiply by the reciprocal. So going to my paper, I take the numerator, and instead of dividing, I multiply by whatever the reciprocal is. So the reciprocal is a squared plus a minus 2 divided by a squared plus 3a minus 4. And that's it. And now we're doing the exact same thing. So we're simplifying that. So like I said, it's the same problem as from page 5. Just that first step is different. So I'm going to give you guys 5 minutes. Get as far as you can with this problem. And I recommend don't use the X box. If you notice, every single one of these quadratics has a as 1. Our coefficient in front of the squared is 1. So this is a perfect opportunity for you guys to practice taking the shortcut. Try not to use an X box to solve this. All right, so like I said, about 5 minutes, and then that'll be the last thing we go over. So if you guys finish up, go ahead and let me know. right, A minus 4 is what you guys got. We will see. Give you guys about a minute or two more. All right, let's take a look at this, guys. So I'm not going to separate this into different factors because I know that I can do these without an Xbox and a window. Again, because I noticed the coefficient in front of the squared is 1. So I'm looking for two numbers that are going to, this first one I don't even really need to do that. I could do that idea, but for the first one, it's a difference of squares. Okay, whenever we have a difference of squares, we take the square root of the first term, square root of a squared is a, plus the square root of the second term, 4, times square root of the first term minus the square root of the second term. So a plus 4 times a minus 4. That gives me the numerator of the first one. A plus 2 can't be factored, so we just keep it as a plus 2. Times a squared plus a minus 2. What multiplies to negative 2 and adds to 1? That would be positive 2, so a plus 2, times negative 1, so a minus 1. What multiplies to negative 4 and adds to 3? That's going to be a positive 4, so a plus 4, times a negative 1, so a minus 1. And the fun part, the satisfying part, is to start canceling things out. So I see I have an a plus 4 in the numerator and denominator. That would be equal to 1. I have an a plus 2 in the numerator and denominator. That's equal to 1. And I have an a minus 1 in the numerator and denominator. That's also equal to 1. So I'm left with, like you guys all found because you're all geniuses, a minus 4. Round of applause. I'm just guessing that at your home right now, you guys are in the middle of your living room clapping as well. So I appreciate that for supporting it. Good job. I think that you guys should be good. That'll give you all the tools you need to complete this assignment. Make sure you guys are looking at the Alex assignment. Make sure you guys get that completed by Friday. Your quarter 3 grades are officially put in, so we are on to quarter 4. I'll be putting some assignments from last week in there. Keep up the good work, guys. Thank you for attending the stream today. I'll be here for like another minute. If you guys have any questions on that problem or anything else, go ahead and ask. If I don't see you Friday, I will be back on. Friday's a review day, so anything from the week, from Alexa homework to this stuff, to the study guide, go ahead and ask me on Friday. I won't be here at 1 o'clock, so those of you who like to hop in during my office hour, I will not be live because I have a meeting. So I will not be able to do a live stream. So just email me any questions you guys have, and I'll still answer them. All right. Michael, see you too, sir. Enjoy Animal Crossing. Have a great rest of your day. You're welcome, Jared. Have a fantastic day. You too, Sierra. Appreciate it. Thank you, Jaden. You too. I will see you guys all